Today we are going to continue the ER modeling. So hopefully we will little cover extended ER modeling, but if not, the problem was mostly we will finish the ER modeling. Then based on our schedule, so we are going to have the first exercise lab. Change in case one more time the flickering, so I'm going to change it into the VGA. Okay, so as I announced last week, I'm going to slightly change our schedule because of additional exercise lab with the AWS, so we have a lot of things to do. So for the database exercise lab 1 regarding to the Orwin software, so I believe that you can do by yourself. It's the downloading and install the Orwin software or any similar software are fine. So you can find many database modeling tools. So I'm going to introduce some of them, but the Orwin software so is the most popular one, but you can use the Workbench from the MySQL. That's also you can use it as a modeling, and not Visio or the not designing tool. Except the designing to the modeling tool, UML modeling tool is fine. So you can use any software, but I strongly suggest to download and install the Orwin software from the, it's called the Orwin Data Modeler. So you can use the free trial for your educational purpose. You don't have to get the license. Then you can do by yourself. So you can submit the final output of the Orwin, the file after modeling. So then to the canvas. So you can do by yourself. If you have any question, you can ask to the Divya, she can help. Especially if you are using MacBook, sometimes the MacBook limit the download and install the program. It's different from Windows. Mostly the My Exercise Lab was based on the PC, the Windows PC. But that's not a big problem, so you can use any the software regarding to the modeling. Instead, the Wednesday, after we finish the extended ER modeling, we are going to start with the GCP exercise lab and first the database exercise lab. So I'm going to introduce how to activate your coupon code and briefly introduce what is the Google Cloud Computing, then followed by the DBS, the exercise lab to create your first the MySQL database on GCP. Okay, so that is our plan. I'm going to change this one, and consequently, I'm going to change the canvas to submit your first exercise lab. So and then this week we have a due of the project which was extended from the last week. So please, we finalized the roofing. So please work together with your teammate and submit the first page. First page require just documentation. Also, I don't expect that you create the perfect proposal. It's kind of proposal of the database project, the page one. So I don't expect that you have a perfect. So where sometimes you can put many requirements which cannot be implemented later due to the time or due to the limitation of the system and so on. At that time, you can revise the page 1, the requirement, while you are doing the page 2, page 3, and page 5, and so on. Okay, so please, however, so it is a good idea to put as much information as possible to your page 1, then it will be helpful for your entire project. Then, if you do not complete the AWS lab, please continue. So we are going to use later the AWS lab. So I'm thinking to offer the extra, the AWS exercise lab, which means not part of the class because we do not have enough time, like the Friday morning or entire day of Friday, I'd like to introduce the AWS as well as how to create the MySQL database and connect. Then after you finish this class, the semester, you have experience on both AWS and the GCP. So for your project, you can select either AWS or the GCP based on your preference. But for the exercise on the SQL database part, so we are going to use this semester GCP. So AWS lab, probably introduced in the classroom the creating database only. The other, the cloud computing part or virtual private network or any other cloud related services on the AWS, it may be covered in the extra exercise. So I'm going to think when is a good time and how long. Then some of you are interested in to get a certificate of AWS, then I will give more information about that during the extra exercise line. Okay. Good news is that Divya, she's very good on the AWS, so you can feel free to ask. Please follow the direction to sign in. I know some of the students are really frustrated at the time. Most of the students who are struggling to sign in is jump or the skip or not the reading the documentation before you create your account. Please read and follow the step by step. It doesn't require any the computer science skill or knowledge. You just follow the direction. Then hopefully you can sign on the AWS Educate, the vocabulary and the bookshelf and so on. Then we are going to have the exercise lab later. My plan for the next semester, we are going to switch the GCP with the AWS, so we are going to use the AWS in future. Okay, any question regarding to the plan? Yes?
On Canvas, it says phase 1 is due on Friday, not on
This Friday?
Yeah.
Yes.
So not the 11th, the 13th.
11 is the
Wednesday.
Wednesday, okay. So exercise lab 13, the GCP lab on 11, and the project phase 1 at 13. Yes, great, thank you. Any other? Yes.
I had problems signing into Vocarium for some reason.
Okay, so just send, even I don't figure it out until I see it, so screenshot is the best. So Canvas, send the Canvas message with the screen.
Okay.
Okay. Most of the time, it's not, your email is not on the class list. Okay. The most of the case, at the time it's my mistake or some of the students register course late. So when I enrolled the student with the CSV file, it was not there. So send the Canvas message and see what's going on. Any other? Okay, so let's start the. That's better. So as I said, we are going to use the handout, the chapter 3 info. So throughout the semester, for our practice and the easy understanding of the database and data modeling, we are going to use the two databases. One is company database, another one is the university database. Okay, so I don't have to explain again what is the company database, what is the university database. Probably you mostly understand the requirement of this. So what we are doing right now is we did meaning from the information we try to build a database. This is our goal throughout the semester. This is a database design. Definitely this one will be created on a computer or server, for example the cloud computing, whatever that is. But we are using the MySQL database as the DBMS. Then It's not just the one step. Instead, we are going to follow the format step of the database design. First step is from the cloud information. So we try to find important related information. So that is the last time called the entity. So we try to find the entity. Eventually, this will be the entity relational, the model, ER modeling. It's a conceptual level modeling. It's a high level modeling. High level means close to the human perception. It's not close to the computer, so we are going to use the database modeling. Among the bunch of different database modeling, we are going to relational database model. We will discuss much more detail about this R. What does the R relational database model means and how we can use such a model. Then using the SQL, data definition language, data manipulation language, finally we are able to create a database. It's a physical database modeling, low-level database modeling, and so on. So what we are doing is this one. This just is step by step. The first thing is the last class we talk about the finding entity. Actually, this is not the entity type. So what we want to find during the first step of the ER modeling is entity type. But we can use entity instead of entity type. It's the same meaning, but for the exam, you should understand the difference between the entity and entity type. Entity means thing, like if we are using the object-oriented concept. So how can you create there are two types of object. Do you remember? Two different the object. First thing is object means real thing, right? So for example, student object, student object, student object, student object. From the real student object, so we can define class. So that is the structure. That is the main concept of object-oriented program. So you define the class, the student, variable, and behavior method. Then using that class, you can create an object in the memory. It's an instantiation. So using, for example, Java, you can use a new operation. So using new, you can create the object. It's a computer object, data structure object in the memory. Okay, like that. This entity is like a real thing. Okay, real student, one student, another student, third student. Among the student entity, we can define student entity type. That is kind of grouping. Okay, so for example, in the company database, we already found what? First entity was department. So this is the entity. Probably in real project, if you are doing the real project, your customer will not give this kind of nice, okay, the description. Instead, bunch of file. Then your job is from the one of the file mentioned about all the department information. Then this is the HR department. This is the admin department. This is the IT department. This is the sales department. Then you realize, so we can identify department entity type. This is a thing. This is an important thing, important information that can be managed by the database eventually. Okay, this is the database, the entity. What other entity type can you find from company? Project. That's what we find. Project. And employee. And also dependent. Then, for easy understanding of the model, we decide to use diagram. Okay. So to represent the entity type, so we are going to use rectangular. So rectangular will be used to represent our entity type or entity, like this one. So this is the first step, the entity. Okay. Then the second step of ER modeling is find all the attributes. So attribute means sometimes it's a variable or attribute. Sometimes it's called a column. So whatever the name is, attribute means that describe the entity type. Okay. So for example, so department from the description first. Okay. From the description, the company is organized into department. So department we identify department as an important thing, entity type. Then each department has a name. So name is a kind of description of department. So as an example, it may be HR, admin, IT, sales, department 1, department 2, like that. So it's the name. And also number. Department number is assigned to each department. And employee who manage the department is a manager. That makes sense. You can find such the employee who manage the department. Then we keep track of the start date of the department manager, and department may have the several locations. So what we're gonna do is we try to identify the name as an attribute. Also number and employee manager. And what else? So start date. Keep track of start date. And location. These are the attributes. What about the other information? Most of the department has the salary information, or their role, mission, and the many other information like the room number, building number. But we are not going to consider such a description. Why? It's not here. The database design is the first based on not my knowledge, not my understanding. It's from a given information by your customer. If your customer doesn't mention about anything, so you don't have to. Later, if you can find some data related to the department, then you can ask, you can discuss. That's a very important step, the discussing or meeting with your customer while you are doing the conceptual level modeling. Because even the customer may not understand their own data, but also they do not know about this. So while you are doing conceptual modeling, you can ask back whether you need this one. Also, you need to consider the first stage, the left-hand side, application modeling. So considering application modeling, so you can you need to manage this. So for example, number. For example, suppose that your customer doesn't mention about the number, there's no information about number. But eventually later when you create the database, you may need. So you can suggest, why not assigning the department number, such a number to each department. So like that. So first guideline is you need to follow the description or the requirement of your database. Okay? Then if you need it, you can add with the discussion or permission of the customer. That is the first step. So we are going to identify as many attributes as possible that describe your entity type. So just like this, we are going to use over to represent each. Then connect to the associated entity type. For example here, so name, this, number, this, manager, this, start date, this, location, this. This one. Any questions? So very simple in this case, but in real, it's not that simple, right there. All information are sometimes mixed up, so we will start with a very simple the example, like the company database. The next thing is similarly the project. Each project has a unique name, and unique number, and located at a single location. It also has the location. After that, we can connect to the question. This project has a name, and the department has a name. So this is kind of another important thing, how to name it. Okay? Some of them are obvious, and everybody agrees, like the name. But sometimes, is it okay to use the same name of attribute for the multiple different? Yes, it's okay. Because this name is for department. This name is for project. However, for better understanding later, it's a good idea like the department name. Or sometimes you can use the D name. D name, or this is a P name like this. So most of the project, when you join the project, your project, the manager, PM, or you're the customer, or you're the company, probably have the naming rule. So naming rule is not the generally standardized. Like for example, in the object-oriented programming, you can use the comma style the naming, okay? Or you can use underscore naming. For example, Python like the underscore, the naming. But on the other hand, the Java like the comma style, the naming. But even though you don't use, it's okay, right? But it's kind of a general agreement. Similarly, in your project, database actually is not very strict for the naming. Even if you are using the A1, A2, A3, A4, it works eventually in the database. But it's not recommended. So best way in the naming is, if you have any standard, please follow the standard in the project and the group. If not, at least the other people, like me, should understand the meaning of attribute. Okay? Not very detailed, but at least like the D name. So we can understand it's a D department name and P name, or the PNO, NO, NBR number, they are popularly used. Okay? So meaningful name, and also not conflict with other. So right now I'm going to use the name provided by your customer. Then later when you create the database, you can change. Okay? So this is the attribute for the project. What about the employee? Employee is the third bullet, social security number, SSN, and the address, and the salary, and sex, and the birthday, DOB. Sometimes the birthday, instead of the birthday, we can use the date of birth, DOB, like this. Then what about dependent? For each dependent, we keep track of their name, and sex, and the DOB, and the relationship. So similarly, we can use the over to go the diagram. So this is the second step. So first find the entity, actually entity type, and their attribute. As many attributes as possible that describe each entity. Then we can understand even from this diagram, we can understand this database. This the company has four important things: department, project, and employee, and the dependent. And also, for example, project, it has information about name, number, and location. Even though, like the project budget, there's no budget information. Even though you believe probably they need the budgetary information, but if your customer doesn't mention about such a budget, you don't have to. Okay, that is the reason your first page of the project is kind of Bible of your project. I'm going to use the first project, first page documentation to understand the requirement, not my understanding. Okay, so first page the project initiation is the most important part of the project. Okay, little bit more about the attribute. There are different types of attribute. So first one is a single attribute. So single attribute means like the name. How many names for the department? So if you read this description, it's not actually some of the words we never use in our daily life. For example, unique. So when you talk about the numbers, I have unique something. So we don't use actually. So unique actually to clarify the requirement of this one. Or so for example, department location is several locations. Clearly mentioned about it has several locations, but the project location is a single location. Okay. Later you will see that's important to design the database. Because of that, actually the description almost kind of translation from the database. Translate from the database to the requirement. So if you read this one, sum of attribute is a single attribute, which means so each one has one the value. So like the one department name, one number, one manager information, and the social security number one, the F. So that is the thing. However, some of them are multi-valued the attribute. So multi-valued attribute is, for example, this one, the department location. It's a multi-valued. Later we will see why the multi-valued is important. Okay? And so in case of the multi-valued, we are going to use double over like this. So multi-valued one is a double over. I'm not going to explain that right now. One, we are going to identify the multi-valued. So multi-valued later is important. Okay. And the third one is composite attribute. So composite and multi-valued are different. Multi-valued means how many different colors. That is multi-values. How many different locations. That is a multi-value. Composite attribute is let me use this one, address. Address, as you know, the address in US has what?
Number.
So street number. And street name. And city name. And what else?
State.
State. And zip code, for example. It's an address format in United States, right? So there are two options you can keep this information. One is entire address, right? So 100 University Avenue, Bridgeport, the city 0604. Another option is separately 100 and the University Avenue, Bridgeport, and city 06604. So if you want to keep this one, you can use a single attribute. Like this one, it's a single attribute. However, if you want to separate like each component, so you can use like the sub the attribute using tree structure. So, for example, in this case, if you want to separate, you can create then street information, city, and the state and zip code, like this. This is called composite attribute. we will see why we identify such a composite attribute. Question. Single attribute, composite attribute. Which one is better? How do I select?
You want to organize it by, say, cities, then you would have an easier time with a composite attribute.
Any other? So when you design this database, how can you decide? Either of them is fine. Okay, you can select it as an option. So how? How to decide? I am asking how. What is the rule over there? It's a application. Okay. If you analyze application like if your application requirement need to access number of customer by state, by zip code, or by access you are accessing the employee information by street name, you need to keep separately, right? Otherwise, you need to code and it will be really complicated. However, if you never used such a component of your address information, just one single address in your application, this one is better. You don't have to separate. So there's no general rule which one is better. Instead, you need to decide. It's your job based on requirement, especially application analysis. If your application need to access separately, this one is better. So at that time, you can use such a composite attribute notation. So either way is fine. We will see later also why composite attribute should be identified in here. Okay? If you are doing the UML modeling, you don't have to. You can create the, for example, subclass of address. You can create the address class or something like that, but relational database does not. So we will see later. So we can use we can find composite attribute. There might be some possibility of the composite attribute over here, but I think the address is one of the typical example. Okay, then couple of more things. After you identify the attribute, you can identify key attribute. So what is a key in general? Key is the key to access, unlock. So important. So because you are in the computer science, what's the meaning of key in computer science, in data structure?
Something that's unique.
Unique, which means you are able to use a key to find the data, search the data. One of the main tasks of general computer and computer science is searching data. Really? So somebody said the security is important. Yeah, right now important, but beyond that, more important thing is we try to use computer to find the data information very fast. If your computer is slow, we don't want. At that time, if data is, as he said, unique, best way, right? No other. What is the benefit of such a unique data? You can, when you have the unique data, you can do what?
Access to that.
Sort, then search very quickly. If your data is sorted with a unique, you can use what? Binary search. For example, very simple binary search is a log n, right? So you can, otherwise linear search is, complexity is n, but this one is log n. Difference is like this, huge difference. So we can save the time by sorting the data. So if not sorted, if not unique, what happened? You can sort the data, but you need to search again among the data because there might be the same value. So key is always important in any database design, any computer science model. Okay, so we try to identify the key attribute in general. So based on what? It's a requirement we need to take a look at again. So let's go back to the first block of the department. Each department has a name and number, even though it's not clearly mentioned. Whether name and number is not, or whether or not they are unique or not, nobody actually uses the same name of department. If UB has a two computer science department, it will be really confusing. There are some. So some of the computer science program is under engineering and as well under art and science. There are, Columbia University has the two computer science department really. So it's very confusing. But most of the case, the company, they don't use the same name of department and name. So at the time you can identify name and number. However, if you see the project, it's really clearly mentioned. A department may have not that one. A project has a unique name. It's a very strong word. Unique means it's really strong word. So that unique number. So we can use the such a number and the name as a key attribute. So if you can find the key attribute, you can use underline for this one. So name, number. Name, number. What about employee? Social security number, right? Is unique. Even though it's not mentioned, social security number definitely unique. What about dependent?
SSN?
There's no SSN information dependent. How do you identify the dependent of employee? Based on this information, you need to know name, but it may be possible your son and my son has the same name, right? You need to identify the parents or the employee information, which means name may be used, but actually it's not really the unique. So at the time, this is called the partial key. So key and partial key. The attribute. In case it's not, it may be possible key, but it's based on the current modeling, it's not the unique. But with the help of other, may be unique. At the time, you can identify there the attribute as the partial key. Partial key is kind of the dot line. So, for example, here we can use dot underline. So this is regarding to the attribute. Okay. What if I do not, for example, find any key attribute or partial attribute from the entity type? Is it okay or not? In other words, key is required for entity. Is it true or false? It's required for the ER modeling here. Even though you don't find any key attribute, it's totally fine. Okay, some of the entity type, they do not have such a key. Okay, so key attribute is 0, 1. What if 2 key attribute? Definitely fine. So like the typical example is the student ID is unique. And also it can be key. The social security number. If you are working for working on campus or working for outside, you have the social security number, even though you are international. Otherwise, if you're local, you have the social security number with your birth certificate. So social security number is a key, and also UBID is a key. So it's fine. So 0 or 1. The key is always 0 or the 1. The attribute. And one more thing regarding to the key attribute. What if I identify, so name is not unique, number is not unique, but name plus number is unique. Is it possible? Yes, it's also possible. You will see a lot of such a case. At the time you can connect like this. That is called the composite attribute. So composite attribute is like the connected line. So key attribute is different from connected composite attribute. Okay, they should work together. Sometimes some of the notation use bracket to clarify this is the composite. So name plus number. So we will see such an example later, but not here in this example. But actually we will see one example later, but this one does not. Okay, that's regarding to the entity type, and attribute. So we have different types of attribute, single attribute, multi-valued attribute, and composite attribute. And also the key attribute we can find 0 or more. So even nothing without the key attribute is fine. We are not use directly this one for the database. This is conceptual design. This can be used for other application, even your daily life. Like to think about I'm going to classify, clean up my room. So when you clean up, you can use the ER modeling also. So important thing you can find. So like the department, the book. So you can put such a bookshelf, and the project employee. Then you can organize using the name of the book like that. If some of the stuff doesn't belong to this, which means it's useless, you can throw away such a thing. So you can use actually the ER model the many ways. So that's if you see the bottom of the second page. So we did the first the step, design of entity type, and the second, the attribute of entity type. Also, yes. Okay. The next step is, as the name implies, ER modeling, entity. Next one is the relationship. So even from the first and second step, from the result of the first and second step, we pretty much understand how company database is organized. But some of the information are missing based on this one. So let's take a look at the first bullet. Unemployed who manage the department. The department is specified the department. So one employee, the manage the department. So we have the information about the manager. But department manager. Actually this manager is also employed. So but here employee using the employee information we cannot find the manager information. So how can we address? So to address, if the certain fact, certain thing is related to the two different entities, so we are going to connect, which is called the relationship. So then we can create the relationship. So like the manage. Instead of attribute of the department, this manage also manager is employed. So connect to the employee and department. Then use the diamond. So third one, relationship. So we use rhombus or diamond to represent and connect. For example, from the description where you're given information by the customer, you identify lead, manage HR department. James, so manage IT department. And also the Shiva manage the sales department. So this is what we identify from the given information or the given data. Then we can See, this one is what? Entity. What entity? Employee. And this one is also entity for department. They are already identified as an entity. So what we need is this one, this one, this one. So we create the relationship between two existing entities. So then connect. So this is the manage. Like this. Okay. We don't have to keep separately the employee information or department information as a part of the manage. Instead, we can connect two existing entities. That is called the relationship. At that time, just like the entity and entity type, this one is called relationship. This one is called another relationship. This is another relationship. You can find many relationships related to the employee and department. So this is called actually relationship type. So we can find the relationship type. So just like the entity type and entity, this is a relationship type and relationship. We are going to use interchangeably. When I'm saying the relationship, that means relationship type. But in the exam, probably you will be asked, so what is a relationship type? That means this one. What is a relationship? This is the relationship. Example, data, real relationship. By combining same relationship, you can create the relationship type and connect two of them. Okay? Let's find the relationship. What else? So each department control project, right? Each department control the project. So which means department control the project. Okay. Anything else? We have you already realized our first example is very nice. It's the italic. It represents such a relationship type. So the subblock of the employee, first subblock, each employee works for one department. Each employee works for one department. So we have works for. It is possible we have two relationships between department and employee, right? One is manager relationship, but we also have the works for. It's okay. Then, may work on several projects. So we have work on employee, work on several projects like this. Okay, so this is another relationship. Then the direct supervisor. We also keep track of the supervisor of each employee. What is a supervisor relationship? So let's think about this one. In a company, we have a CEO. CEO supervise executive, the employee. Executive 1, executive 2, executive. Executive member supervise the manager. Manager, manager, manager. Manager supervise employee. Like this. Such a hierarchical. But supervisor, but this supervisor is also supervised by another employee. So at the same time, employee can be supervisor as well as a supervisor. So for example, Lee supervised James. And James supervised Shiva. James supervised Smith. Like that. So supervise. supervise. So we can create the supervising relationship here. Supervising. But this one is what? Employee. This one is what? Employee also. So we can find the relationship between employee and employee. This is called the self-reference. So it is possible, even you can create the relationship for the same entity type. So at that time, we can create the here, supervising, then employee can supervise another employee. So this is also possible self-reference, the relationship. Okay. Anything else? Oh, each employee may have number of dependents. So which means employee has the has. Dependent employee has like this. Right? So any other? Pretty much we found the most of the such a relationship. Okay? Yes?
Professor,
Mhm.
it says each employee works for one department.
Yes.
So we have a relationship there saying work for. But
Mhm.
also employee work on several projects.
Yes.
Will it not be multi-valuable?
Yes. So what she is asking is, what about the first subbullet of the employee? It says that each employee works for one department. It looks like a very strong word, one department. But the may work on several projects. Several. It's a different meaning, right? So one department or the several projects. So that is the exactly next step that we need to identify before we explain about such a thing. Why don't we go back to the elementary, third or fourth grade of your math class? When did you learn the set theory first time in your math? It's a third grade, first grade. So you use this kind of diagram to represent, right? So we have element A, B, C, element 1, 2, 3, like this. This is called one-to-one mapping. Sometimes we have this kind of thing, many-to-one mapping, or many-to-many mapping. So you learn this one. Similarly, here, for example, Lee works for HR department, but Lee cannot work the other department, right? So James works for IT department, only department, because the description says that this one. If we map this one to this, it's a one-to-one mapping. It's a one-to-one relationship. So relationship has a different types of relationship. First, one-to-one relationship. Okay. However, what about works on project? In case this one is a project, works on project. Lee works on project 1. Also, Lee works on project 2. James works on project 1. So on. This is many to many, because employee works on many projects. Also, one project, how many employee? Many. So we have many to many relationship. Another one is one to many relationships. For example, employee has how many dependent? Many dependent. However, dependent, how many employee? One employee, right? It may be possible both parents working in the same company. It's many to many. But here, let's say the one employee, many children, dependent. Okay? So there are different types of relationship. That's clearly mentioned in the description. So we need to identify this is called cardinality. So relationship cardinality. There are three different types of the cardinality. One is 1 to 1, 1 to many, or many to 1. So we use M or N to represent a many side, and many to many. Okay. Any other case? Actually, there are many. What about this 0 to many? We will see such an example. But roughly using this cardinality, there are three different cases: 1 to 1, 1 to many, or many to 1, or many to many. So we are going to identify such a cardinality. For example, the managing relationship is what? Which one? One of these. 1 to 1, 1 to many, many to many. 1 to many means one employee manage many departments, only one. So if you read the first, it's a manage one department. So an employee who manage the department, it's a one department. So this is a 1 to 1 relationship. We are going to use such a cardinality. The line with the connected line to the end, 1 to 1. What about this department control project? It's a 1 to 1, 1 to many, many to many. If you read the description, control part, second blank, each department, one department control a number of projects. So 1 to many. Which one is one side? One side. The one is the department. It looks like a simple, but later it's really many students confused. So one department, so many side of project. Okay. And what about the work zone? Employee works on many projects. Project has many, so many to many. What about the supervising? How many supervisors do you have? One. How many supervising? Many. So 1 to many. And this one, 1 to many. And what about the work for? Many. One employee work for the one department. And many. So it's a many to 1 to many. So which one is one side? Department. One. Many employees. Okay. So this is the 1 to 1, 1 to many, many to many cardinality. There is one more thing. Plus, if you read some of the information, like this one, department should have manager. It's a mandatory. What about the employee? Employee should be manager. Some of them are manager, some of them are not. So which means this side is optional. However, department to the manage is a mandatory. In case of mandatory, we can use double line. So double line represent is a mandatory participation of the relationship. Okay. But this mandatory or the optional is very strong. Sometimes it's not very clear on your description from data. In case it's the obvious, what clearly mentioned, we can use. So for example, employee dependent. In case of dependent, it should be double line, right? Not all employee has the dependent. Okay? And project. In case of a project, it should have controlling department. However, department may not have the project, like the HR does not have any project. And the work zone, it's like let's see the work zone. May work on, may means it's optional. Some of the employee works on the project, some of them are not. Also, if you see the project, it's not clear whether there might be project but no employee there. It may be possible just to create the project but nobody assigned. So both of them is optional. But if that is clearly mentioned, each project should have at least one employee to initiate. At that time, you can use double line. It's a very strong condition. So you should be careful when you decide the double or single. Double means it's a mandatory participation. Okay. Then we did step 3 and step 4, weak entity. We identify the entity, but what about the department, project, employee? They have at least one key attribute. So we can use such a key attribute later to search the data. What about dependent? Dependent does not have such a key attribute. Instead, it has only partial attribute. However, if we use this relationship has, so who is your employee? Then we can identify the specific dependent. Because of that, dependent does not have the key attribute, but with the help of the other entity, we can find the data. At the time, the entity is called, where is that? Yeah, weak entity. So weak entity means, the other one is strong entity. Strong entity means with key, at least one key. But the weak entity does not have or only partial key. Partial key. To represent this weak entity, we can use double rectangular. So we can use double rectangular. Because later when we create the database does not allow such a partial key. It should have the key. So we can use such a double rectangular to represent the weak entity. Then, one more thing. How can you identify the dependent? Using employee. So we can use this has relationship as the identifying the relationship. Then use double rhombus. This is called the identifying relationship. So we can use the identifying relationship to identify the specific entity of weak entity, dependent. Okay? Mostly done except the one. That is, why don't you take a look at second sub-bullet of the employee. We keep track of the number of hours. Meaning is, for example, Lee works on P1, how many hours? 10 hours. Lee works on project 2, how many hours? 20 hours. James works on project 1 how many hours? 10 hours. These hours, can you find the number of hours here? No. So how can we put such an information? Probably it's an attribute. Yeah, attribute maybe, because each employee works on some number of where? Employee. But how can we represent a different project? So it's not easy. What about project? Project, number of employees, right? So instead, why not using works on relationship? So Lee works on project 1, 10 hours. Lee works on project 2, 20 hours. So we can put hours as an attribute of relationship. So attribute is not only for the entity description. Attribute also can be used for relationship. Okay. Specifically, is many-to-many relationship as the attribute, right? Why? Because it's the many-to-many the relationship. It has the some description, number of hours in between. So only many-to-many. Actually, one-to-one, one-to-many may have the attribute, but we have one side. So we can put all attribute to one side. But many-to-many, we cannot move to such a attribute, number of hours. So we can keep number of hours attribute on works on. When you test it, your Arwin software or any other software, when you create the many-to-many relationship, it will be slightly different from others. Sometimes it asks whether you are going to propagate, which means create another entity, something like that. Because many-to-many relationship has such a characteristic. We will see more details later. Okay? But right now, only many-to-many relationship may have such a attribute. For example, number of hours. Okay? That's pretty much not everything. So probably the 90% of the ER model, which means very simple. ER model, one of the benefits of using ER modeling is intuitively you have a use in your mind, in your daily life, in your modeling, in your the software engineering. But right now, in this class, we formalize the step by step. Okay, so mostly entity and relationship, but different types of the entity or strong entity or weak entity. If we have the key, strong entity. If not, weak entity. In case of weak entity, we need to create a relationship, which means relationship also has the different type: one-to-one, one-to-many, many-to-many. Okay. In case of many-to-many, it has the attribute. We will see attribute later. Then identifying relationship is a double numbers. Okay. And also we can specify the mandatory or optional, single line or the double line. Also we can use the 1, 2, their cardinality over here. Then regarding to the attribute actually describe the entity and relationship. So in case of the unique, we can identify as a key attribute. Otherwise, it's just normal. And sometimes it's a partial key. It can be related to the weak entity. This. And the composite attribute, we can use like the tree structure to represent the attribute. And so single attribute, multi-value. Multi-value is like the locations double over. And the composite we have seen. Then, from this diagram is the same as this. Actually, this is just the plain in English, but this one is based on the ER diagram. It's a notation. Actually, same meaning. Then, the benefit, one step close to the structure information, structural data. which means we are able to create the database. From here, not easy. I know you are smart, so you can directly create the database from here. This is a simple example. In real life, no way. So we can do such a conceptual modeling. From here, it's one step close to the database. Not yet, but it's very close. Okay? So this is a notation that we have used. Anything that I missed?
Derived attributes.
Derived. So for example, so it's not mentioned here. For each employee, how many hours you work? You need to sum of hours, right? For example, Lee works on how many hours? 10, 20, 30 hours per week. So if your requirement is or the description, total number of hours, you don't have to keep it in your application. You can calculate every time. It's the overhead. Why not? Include such a number of total hours, but this one should depend on this. You can calculate derived. So at that time, you can use dot over for the derived. Okay? It's more application specific, the requirement. Your customer may ask, so this one will be used a lot, so please keep this information in the database. At the time, you can actually calculate, either add as a derived. So that is the derived attribute. You can use the dot, the over. Okay? Any other questions? What about I have seen the other ER modeling that doesn't use this notation. It's okay. Okay? As I said, there's no standard. So depending on the author or depending on the ER modeling tool, they are used. Even the Irwin software use different one. Even UML can be used for the UML modeling, can be used for the ER modeling. So please, but I believe you can intuitively understand the meaning of which one is entity, which one is relationship, which one is attribute, which one is key. Sometimes key is really key, left-hand side, okay, instead of underline. So, but in this classroom, only for the kind of convenience for me to grade and so on, we are going to use this notation provided by the textbook or Irwin software. So Irwin software different. The notation like the industrial, the standard, or the UML. So please use one of them, provided by the Irwin software. Or if we are using the software tool, you can use. So this is an example of the first ER model. Good news, as you can see, understanding the ER modeling is not complicated. It's very simple. And the problem is real example. When you encounter the real example at the graduation, you join the project. Like your project is going to be the scientific database. I do not know anything about biology. So domain knowledge is very important in your experience. Like whether this one is go for the identifying relationship or the strong entity. Somebody may decide the name can the additional dependent attribute, even though it's not given. So why not using the social security number? Then it will not be the weak entity. Okay. Sometimes it can be the composite, sometimes not. Based on the application analysis, you need to decide. There is no general solution or answer. Sometimes based on your experience. So if you search the job, sometimes job description asks 3 years, minimum 3 years experience on conceptual design on financial data, something like that. Okay, so this is an ER model, which means you need to practice more. So first, the homework is in your exercise lab. If you go to the exercise lab, you are going to create the ER model for this company database. That's the one thing. There is a homework of the exercise lab. Why don't you model? Okay, so I think the music store, I cannot remember, but there is an additional. So at least several times you need to practice with a simple database. So one is company database, another one is the exercise lab homework. You need to submit the 2 copy of ER modeling. So there's a way to save as a JPG file. So you can submit the JPG file of your model. Or ORIN file may be fine, right? ORIN file. Or if you are using the tool which DBR and me do not have, so JPEG file is the best one to see whether you create. Okay, one more homework. This is what I'm doing. First, handout. I can do. This is a homework by Wednesday. The first page only. First page only. By the Wednesday. This is the midterm exam on spring semester. Midterm exam. Exactly same. I actually make the question from your homework. Actually, your main homework is not this one. Like this. Why don't you find half-page description of database from internet and Google, textbook, any material, or you can create by yourself. Okay? But if you search the Google just simply the sample example of relational ER modeling, top one is MBA, or very popular, the database. Some of the students already did. If you cannot find any other, it's okay. But I'm going to select one of example from your homework for your midterm exam. So this is actually the homework from one of the student, online bookstore, the system. Okay. Then, for me, it's very easy to ask a question for your midterm. So if you by the next week, Monday, okay, so 1 week, so find the sample like this one, like the online bookstore. Find the sample description of your database. You can use any material. You can create your own database by yourself. Then answer ER diagram. Then one of the best one will be used for your midterm exam. So if you are lucky, your homework will be part of the midterm exam. So 20 points actually out of 100. So by Monday, so I'm going to create the canvas, the ER modeling, the assignment or whatever I'm going to create. You can submit the one PDF version or Word file. It's okay. Not JPEG, so PDF or the Word file. So one half page, the description, half page, your answer. Then I'm going to combine all your the 1, 2, 3, 4, 5, 6, 7, and we have 11 students. So 11 ER diagram you can see for your study. Okay? So for your midterm exam, one of them will be selected, used for your midterm exam. Then that will be used for 3 more questions, like the creating relational database and creating the SQL, data definition language, data manipulation language. So next page. So by Wednesday, please use this one. You don't have to submit to the Canvas. Okay? Use this one. Just follow this step, entity, attribute of this one, relationship, and the attribute of if any attribute, decide the cardinality, decide the participation, optional, whatever. So using that step, the answer, your handwriting only. You don't have to write handwriting. First practice, okay, on Wednesday. Then later we will use this one again to create the relational database model. Okay? So keep it. So but the next time bring and after grading we will return to you. This is the homework by Wednesday, and another homework is by Friday we have a due, and Monday submit your sample database, okay, and also answer. Then I'm going to share with all the other students your answer. Then that can be the study material for your midterm exam. Okay, any questions? Okay, I'm going to clarify once again through the Canvas message. Then once again, Wednesday, this. Okay, bring this paper. Don't forget this paper, only handwriting. And Friday, due of this. Usually grace period by the weekend, but the extended one, no. So you need to submit on this hard due date. And by Monday, find your sample database. Please note half pages, not too details. Some of the students submit 3-page long description, and even he or she didn't know what is the answer exactly. So you're the ER diagram. So far, handwritten is okay. Then take the photo, but the better way is please use the tool. Okay? So you have to figure it out. That is by Monday. Okay. What time is it now? How many more minutes? Oh, it's already passed. So we covered most of them up to. So this is the same as this one. For example, the one-to-one, manage one-to-one. You can see start date here, but this start date because it's one side, so it can be moved the department. That is the reason it's a start date. However, many-to-many is the number of hours should be here. So it's exactly same as our ER diagram. And we did this, and the live one is also done. And everything is done. It's the same, almost the same as this one, but a little bit different notation. 1,1 and 4. We will see next class. This is called the different notation variation, min-max notation. So I will going to explain the min-max notation. Then it's the same as the UML, like this, and the couple of other variation. Then we will talk about the extended ER modeling. We may need 20 minutes, then covered by the GCP lab as well as the database lab. So next class, you don't have to do anything, just bring your laptop. Anyone who do not have a laptop? Okay, so bring your laptop and should be connected. I think it might be okay. Anything?
No problem.
Yeah.
I just wanted to.
Any questions? Okay, thanks so much. There are a lot of things. As I said, this is kind of combined. The 3 undergraduate the database design as well as the graduate level. So there are a lot of things. Even this semester we are going to cover the AWS, but it will be worthwhile for you guys. Thank you.